Andrew, you awake? I'm just about to come wake you up. Come on, man. Keep your head up. So if we want to evaluate this function for when x is -4, 0, 2, that's another way of stating the same kind of question you answered on your quiz, which is like, if this is the domain, what's the range? And so you just set up a little table. So if I want to evaluate, say, f of -4, I need to evaluate f of 0 and f of 2. I'm just going to plug in those numbers into x. And this is something you can do in the calculator. Let me zoom in for you here. So you probably already have a calculator because you did a problem like this on the quiz, but if not, go grab one or just kind of look on with somebody around you. We'll go grab one too. And we're just going to use the table function for this. We don't need to evaluate these all independently. So just like always, you want to clear your memory. So let's press second plus 712. Okay, so clear your memory. Just again, because we kind of changed things in pre-calculus, and I want you to have all the default settings here. Once you get the memory cleared, you're going to go to y equals, and you want to type in your equation, -x plus 4. And then we want to look at the table. That's going to be where the quickest way of finding all these values. We could type them all in individually, like, you know, -4 plus 4. But this is probably going to be a more accurate and faster way of doing this. Any questions about how to input this into y equals? You guys good with that? All right, so go to the table. To get to the table, you hit second graph, and it'll come up with a table. This is a table that you could scroll through. Last time I showed you how you can like input custom values. You don't necessarily need to do that, especially if the inputs you're talking about are integers and they're kind of small numbers, so you won't have to scroll very far to find any of these. So if I scroll up, what I'm looking for is what happens when x is -4. So what is f of -4? 8. Right, it's just the y value. F of -4 is 8. The next one you could probably figure out in your head. Like if I plug in 0 into this equation, what do I get? I should get 4. And I'm going to double check that with my table. When x is 0, y is 4. I can look in the table again, or I mean, this is probably pretty easily to do mentally, right? -2 plus 4. But just to stay safe, I'm gonna refer back to the table. -2 plus 4 is 2. So these are going to be our solutions here. And when it says write it using function notation, that's what this means. Okay? Oh, it didn't say function notation. It says set notation. Oh, so we're gonna have to write this a little differently. So this is how you would write it if it said write it in function notation. So my final solution here, if I want to write it in set notation, would be with these little curly brackets, 8, 4, 2.
That's set notation?
Yeah, so set notation is just those little squiggly brackets where you list out all the values. So how we've been writing, you know, when we had a discrete situation, we wrote the domain and range as a list of numbers. We're writing it using set notation. I don't know that we ever called it that, but that's what it is. So yeah, when you're writing these relationships, this is f of x equals y. So just know that what goes inside the parentheses here is x. The input is on the inside of the parentheses. The output is what f of that x equals. So f of x equals y. All right, let's try number 2. What is g of -4, g of 0, and g of 2? So this one, you probably don't even need a calculator for this one. You're just plugging in those x values. So like, what's 5 times negative 4? Yeah, negative 20, right? Now, if it's not super obvious, definitely recommend using the calculator and looking at the table. But when all you're doing is just multiplying by 5, I mean, you're probably going to be faster without the calculator than you would be with the calculator. 5 times 0 is 0, and 5 times 2 is 10. So my range here for the given domain is negative 20, 0, and 10. All right, so just to make sure that you guys know what you're doing here, I want you to do 3 through 6 on your own to see if you can do it. Yes, sir? Oh, okay. Are you sure? Oh, sure. All right, so I'm going to give you like 5 minutes, or we'll see how long it takes, and I wanted to see if you can do 3 through 6. So even though 4 through 6 has slightly different directions, you're basically doing the same thing, okay? So like, for instance, number 4, I'll just kind of get you started there. You're looking for what is s of negative 1, s of 1, and s of 5. Okay. So let's see how well you did. Number 3, I got 15, 7, and 3. Is that what y'all got? We're good there? Okay. Number 4, I got my range to be 12.25, 11.75, and 10.75. Anybody get anything different? Okay. Number 5, I got 1, 7, and 19. And number 6, I got 7, 3, and negative 5. Any questions about that? All right, well, let's look at number 7. It says, let n of t be the number of DVDs you have in your collection after t trips to the video store. Explain the meaning of each statement. So this is really about trying to interpret this function notation. Okay, so n of t is the number of DVDs, t is the number of trips. First of all, what's the independent variable here? Yeah, trips to the store. I'm going to make a little note here that the independent is trips to the store. And the dependent variable is what? Yeah, the number of DVDs you have in your collection. Okay, so let's look at the first one. N of 0 equals 8. So the input is this number inside of the parentheses. The output is what it's equal to. So the input is the independent variable. So how many trips to the store does this indicate? 0. And what does the 8 represent? Yeah, how many he has. So he went to the store 0 times. So what does that mean about that number 8 in this context? He already had 8 DVDs, right? So you have 8 DVDs before going to the store. Now, if we have like n of 3 equals 14, then that means that you will have 14 DVDs after going to the store 3 times. Just kind of box this off. What about C? What does that mean? N of 5 is greater than N of 3.
You have a greater amount of DVDs when you go to score 5 times than 3 times.
Perfect. That's exactly what it means. So let's write that down. You have, or you will have, I guess, you will have more DVDs after going 5 times than if you go 3. You have more DVDs if you go 5 times than if you go 3 times. Now D is a little tricky here. It says N of 7 minus N of 2 equals 10. So let's take this just piece by piece. What does N of 7 mean? Yeah, it's the number of DVDs you have after going 7 times. What does N of 2 mean? Right, so if the number of DVD, or I'm sorry, if the difference of the number of DVDs you have after going 7 times and the number of DVDs you have going 2 times is 10, what does that mean about the number 10? What does the 10 represent? The amount of DVDs that what?
Wouldn't it be 5 trips in the store? Okay.
So you will have 10, or you will not have, but pick up 10 DVDs between trip 2 and 7. Basically what that means is, like, if you look at the amount of DVDs you had on trip 7 and you take away the amount of DVDs you had on trip 2, you've got 10. So where did those 10 DVDs come from? Well, they came from all the trips from 2 to 10. Or 2 to 7, rather. That one's kind of weird, but... Alright, well, let's take a look at the back here. Find the value of x so that the function has the given value. Okay, so in this case, I'm telling you the value of the function, not the value of x. Like, if I was just giving you the value of x, you just plug it into x and then calculate it out. But if I give you the value of the function, that means you need to set the equation equal to that number and then solve for x. So that the directions say find x. So that's sort of a clue that, hey, you should be solving for x, not plugging something into x. So it says if b of x is negative 3x plus 1 and b of x is negative 20, find x. So we have negative 20, that's the value of the function, so I'm going to plug that in here. That's essentially your y. So negative 20 equals negative 3x plus 1. We spent a good deal of time trying to solve something like this. Yes, sir? Of course. So what would be my first step?
Subtract 1.
Yeah, subtract 1. So that would be negative 21 equals negative 3x. Divide by negative 3. And I get x equals 7. Right, so really this type of problem, you just kind of have to know what you're reading here. I think you guys will be able to solve it pretty easily, especially given that you have a calculator. But you have to sort of know how to set it up first before you can actually solve it. So number 9 says that r of x equals 33. So we're going to set our equation equal to 33 and then solve for x. I'll start by adding 3 to both sides. That'll give me 36 equals 4x. And then divide both sides by 4. So I get x equals 9. Again, you're just setting your function equal to something and finding out which x value has that output. So before on the front page I was giving you inputs and asking what the outputs are. Here I'm giving you an output and asking what the input is. Now this next one you might want to have a calculator handy because we're going to be dealing with fractions. So what are we going to set our equation equal to in this case? 2. Yeah, so we've got 2 equals negative 3/5 x minus 4. Start it off by adding 4 to both sides. That'll give me 6 equals negative 3/5 x. And then this is where I'm going to break out the calculator because I want to divide by negative 3/5. And I don't want to make a mistake because I don't know how to use the calculator. So let's see. 6 divided by, then I'm going to do alpha y equals to get my fraction set up. Negative 3/5. Hit enter and I get negative 10. Now, for this whole first semester, we're going to be talking about specifically linear functions. I don't think we get to quadratics until later. I could be wrong about that, but for the foreseeable future, we'll be discussing linear functions, which are functions that have a constant rate of change. So last time we looked at how to determine whether or not a function was linear, and today we're going to start the process of graphing. We're going to get a lot more into that in the next unit, but for right now, we're just going to be doing kind of what we did on the front page of this notes, where we're just going to be identifying y values that match up with the x values, but we're also going to be plotting the points. So plotting these points are going to be pretty important too. Let's look at number 11. There's a function and a table and a graph. Now this is 100% going to be a calculator thing to make this go by a lot easier. So go ahead and get your calculator ready. Type in y equals, clear out whatever equation you had in there, and type this one in, 1/2 x minus 2. If you don't have a calculator, just look on with someone around you. It's okay. So alpha y equals, get my fraction ready, 1/2 x minus 2. And then we're going to copy down all the values that we're interested in here. So like negative 4, comma, negative 4, negative 2, comma, negative 3, 0, comma, negative 2, 2, comma, negative 1. I'll have to scroll down here a little bit to get to 4, 4, comma, 0. All right, so I've got those 5 coordinates. And so now I need to plot them. So negative 4, comma, negative 4, negative 2, comma, negative 3, 0, comma, negative 2, 2, negative 1, and 4, 0. So I've got those points down. Now I just need to draw the line. The line should just go straight through the points. If you notice that you have a point that's not in line with the others, that will typically indicate that you just either you wrote down the wrong thing or you just graphed it improperly. But they should all be in a line if you do it correctly. Any questions about that one? All right, well, let's do the next one, number 12. Okay, go back to y equals. I'm going to type in the equation. Clear that out. 1 minus 2x. Go to the table. Start copying values down. Negative 2, comma 5. Negative 1, comma 3. 0, comma 1. 1, comma negative 1. 2, comma negative 3. Yes, sir? Oh, did it run out of batteries?
Yes.
All right.
All in there.
Well, yeah. All right, so when we plot these, negative 2, comma 5, negative 1, comma 3, 0, comma 1, 1, comma negative 1, 2, comma negative 3, all of these lie in a line, so we're good to go. Have you all done this before? Like plotting using this strategy of like filling out a table, and you can actually use this strategy to plot any function. this is sort of like your baseline strategy if you don't have any others to graph something, is just to come up with a bunch of points and then play connect the dots. Number 13. 13 and 14 are really, you don't handle these any differently. You just go to your calculator, type in the function into y equals, and then just start copying values from the table. Oop. So put this over here so you can see it. So we've got, oh, here the whole table is blank. So what do you think might be a good place to start here? So like, -2 is probably not a great place to start because you can see that my y value is -8, and that's going to be off the graph.
Oh, we're doing -4?
So, well, -4 is going to be way off the graph, right? -4, -14. So the first one we can actually fit is this -1, -5, so that's probably a good place to start. -1, -5, 0, -2, 1, 1, 2, 4, and 3, 7. Well, we can't really fit 3, 7, can we? We'll just fit what we can on there. So -1, -5, 0, -2, 1, 1, and 2, 4 is about all we can fit on there. And that's okay. You just fit as much as you can. Play connect the dots and you're done. Ooh, number 4's got some fractions going on here. So when we try to create a table with fractions, you want to try to pick points that are easy to plot. So I'm going to type this in, just like I did all the other problems. So I'm going to fit that on there. So negative, and then I'm going to throw in my fraction, 3/4, x minus 1. Should look like that. Go to the table, and I want to pick values that are sort of easy to plot. So I'm looking for numbers that are not fractions here. So -8, -5 isn't really going to fit on there, but -4, 2 will. And then I'm just scrolling down until I can find ones that are easy to plot. So like 0, -1, that'll work. 4, -4. It looks like that's probably going to be the last one that will fit here. Because I have like, I'm just going to keep writing a couple more, but I'm not going to be able to plot any of these. 12, -10. So I'm just going to, really I'm only going to fit these 3 points on there. So I got -4, 2, 0, -1, and 4, -4. Yeah, that slope is not very convenient. There you go. So any questions about graphing from an equation? So let's look at the last problem here, number 15. It says the function b of m is equal to 50m plus 150. It represents the balance in your savings account after m months. The table shows the balance in your friend's savings account. Who has the better savings plan? So we're talking about savings plan. What we want is to have the greatest rate of change. Like which account is going to be adding more to your amount every month. So if you look at the equation, this 50m, 50, and we're going to talk a lot more about this in the next unit, but 50 is the rate of change in this equation. Let's find the rate of change of this linear pattern. So my change in y, let's see, how do I get from 330 to 410? What do I need to add? 80, right? So 80, and this is plus 2. So my rate of change here is 80 over 2 or 40. So you're getting $50 per month added to your account, and your friend's getting 40. So who has the better savings? Yeah, you do, definitely. You do. Okay, and what that is based on is the rate of change. Okay, this rate of change is $50 a month. This rate of change is 40.